Okay, this video is about finding probabilities using two-way tables. The table below shows the orders of 120 people at the motorway restaurant. So we've got tea and coffee, fish and chips, bacon and egg, and cottage pie. The manager conducts a survey and asks the customer what they've just ordered. Find the probability that the customer A did not order cottage pie, 2 ordered tea, 3 ordered coffee but not fish and chips. Mr. and Mrs. Sudbury have just finished their meal at the restaurant. What is the probability that they both had bacon and egg and tea, neither of them had fish and chips, and at least one of them had cottage pie? Okay, the first thing to do is to work out the totals. So you need to add an extra row, an extra column on your two-way table. So these are called the totals. So we just add them up. This is 72. That's 22, 25, 25. And then we do 19, 22, and 7 to get 48. 22 and 19 to get 41. 25 and 22 to get 47. 25 and 7 to get 32. We add these two up and these three up separately and check that both ways we get 120. Right, we're now ready to use our table to calculate probabilities. So the manager conducts a survey and asks the customer what they just ordered. Find the probability A1 did not order cottage pie, ordered tea, ordered coffee but not fish and chips. So the probability that did not order cottage pie, and what you try to do is you annotate the diagram. So these are ones that ordered cottage pie. These are ones that did not order cottage pie. So it's going to be 41 plus 47 out of the total 120, which gives you 80 out of 120 and cancels down to 11 over 15. Find the probability that the customer ordered tea. So the probability that the customer ordered tea, well, that's going to be that one there out of 120. So it's going to be 72 out of 120. Find the probability, sorry, that becomes 3 out of 5. Find the probability that ordered coffee but not fish and chips. So just using our diagram again. So we want the probability ordered coffee but not fish and chips. So that's the probability of not fish and chips given that they had coffee. So not fish and chips, this is ones that had coffee, and these are going to be out of 48. So that's going to be 22 plus 7 out of 48 because we knew that they ordered coffee. Okay, so it's sort of a conditional probability which gives me 29 out of 48. Right. Final part. Mr. and Mrs. Sudbury had just finished their meal at the restaurant. What is the probability that they both had bacon, egg, and tea? Neither of them had fish and chips, and at least one of them had cottage pie. Right. So they both had bacon and egg. That means if Mr. Sudbury has bacon and egg, that's going to be 25 out of 120. But now you take Mr. Sudbury out of that selection, you still have Mrs. Sudbury, so it's going to be one. There's now going to be one left, so that's 24 out of 119. There is one less person for choosing the second person, so that's going to give me 5 over 119, which is approximately equal to 0.0420 to 3 significant figures. The probability that neither of them had fish and chips. So these are the ones that had fish and chips, these are the ones that neither had fish and chips, so that's going to be 79, 49, 47 plus 42 out of 120 for Mr. And then for Mrs. it will be 78 out of 119, which gives me 1,027 over 2,380. And then finally, that gives you 0.432 to 3 significant figures. Then finally, the probability of at least one. Okay, at least one is quite an important concept in probability, and it's always found by doing 1 minus the probability of neither of them had cottage pie. Otherwise, you would have to work out the probability that they both had cottage pie, the probability that Mr. had cottage pie and Mrs. did not, and Mrs. did and then Mr. did, and add them all up. But it's easier just to do 1 minus the probability that neither of them had cottage pie, because that will ensure at least one of them has cottage pie. So it's going to be 1. These are the ones that did not have cottage pie, so it's going to be 1 minus 88 out of 120 times 87 out of 119, which gives me 276 out of 595, which is approximately equal to 0.464 to 3 significant figures. So this has been a video to show how to use two-way tables in order to calculate probabilities. I hope you understood, and I thank you very much for watching.